This section is about differentials and the local linear approximation. The local linear approximation is going to be using our tangent line equation to estimate nearby values of our function. Differentials refers to a change in y with respect to a change in x. So we're going to be using our derivatives to talk about those. So when we're considering our tangent line equation, we're going to be solving for f of x because we're going to be estimating our value at some f of x. So we've got our y value that we know plus our slope at that y value, or our instantaneous rate of change, the value we're trying to estimate at x minus the value we know at c. So this right here is our local linear approximation. So it's not something you have to memorize so much as you need to know that you're just solving for the unknown value and we're going to estimate it. So look at an example of that in just a moment. Using that, we can then talk about a differential. All right, this corresponds to the section 4.8 in your textbook. All right, and I've reproduced a bunch of the sections just for our use. So delta x is going to be referring to that distance away from c. So in this case, it's talking about x plus c. That's a distance away from c. So when we're considering this difference in the y's, right, that's going to be the derivative times the difference in the x. So if we're looking at our equation up here, it's this part of the equation. All right, so this part is called the differential. And we're going to write that in terms of dy and dx. So we've got a definition here. Let y be the function f of x and it be differentiable on our interval. That means we can take the derivative. The differential of x then, dx, is any non-zero real number, and the differential of y is denoted by dy. So our differential then is dy equals f prime times dx. So let's talk about why that is. Well, that's the case because y equals f of x, and when we differentiate that, we get dy with respect to dx equals f of x, f prime of x. If we multiply both sides by dx, that differential with respect to x, we get this equation here. All right, so then we can do our function, our derivative, our differential by multiplying both sides by dx. So these are examples of that process. Take a minute to write at least some of those down. All right, so let's look at a tangent line approximation example. Right, and on the right-hand side here, we've got a visual representation of it. So we're looking at the point 0, 1 as the one that we know. Change colors. And we're going to be approximating, all right, values nearby. So when you approximate, that means you're going out on this tangent line. So you're not actually on the function, you're close to it. You're getting an approximation. So we've got f of x minus f of c equals f prime of c times x minus c. So that means we need to figure out what f prime of our function is. The derivative of 1 is 0, and the derivative of sine is cosine. So then we've got f of x minus our y value at that input, which is 1, equals our derivative at that point, so cosine of x, which is 0, times x minus c, which is 0. Cosine of 0 is 1. So our tangent line approximation is going to be f of x equals x plus 1. And then we could say, well, we want to approximate it at pi over 4. We put pi over 4 in for x, and we get an approximate value for that. So I've color-coded the I do, we do, you do. It's our kind of red, green, and blue. So we're going to find the tangent line approximation for the functions that follow. So I've got the function x squared and the point 2, 4. So considering that, my derivative of that function is 2x. The point I'm considering is at 2. So my derivative at that point is 4. All right. So we're ready to use our equation then. F of x minus f of c. All right. From now on, I'm going to shorten this. So instead of putting the f of c on that side, I'm going to just put it on the right-hand side. So we got f of x is going to be about 4 plus 4 times x minus 2. This is going to be 4x minus 8. X minus 4. So this is our tangent line approximation. And then you're going to use it to complete the table above. So we plug in those values into this approximation. Where t is going to be our tangent line approximation, and f of x is going to be our actual function x squared. So what I'm doing right now is I'm plugging these values in. So for the top one here, I did 4 times 1.9 minus 4. That gives me this tangent line approximation. And for the top one, you do 1.9 squared. Using the actual function, that would give you this value. So I'm just going to go ahead and do those and write them all in our table. You'll notice then that our tangent line approximation is close to the values of the actual function, but not quite the values of the actual function. Because if we're thinking about our curve, our tangent line is going to differ from the actual values on the curve. Right, so the actual values on the curve would be like this purple one, and this pink one would be like our tangent line approximation. We're slowly getting further away. All right, so I'm going to just quickly do the next problems for our We Do video, and then you have one to give a try.